Hello everyone. So let us now discuss today's topic, prefix sum, right? So this is DSA A2Z course, right? Okay, let us say. So let us start with what is this prefix sum, right? Today we will be going with the NEET code 150 problems for today, and also from this day we will be going with NEET code 150 problems. So let us see what is this prefix sum actually mean. Now, the name itself says us that if you see, we would be listening this postpone. Post is nothing but the afterwards, right? Nothing but the exam is postponed is does mean that the exam date has been extended or exam date has been moved forward or nothing but has been delayed, right? Now what does this post prefix mean, right? So in also chemistry and many other subjects we knew that this is our prefix and the one which comes before is our prefix and the one which comes at the last is our suffix. Now by only looking at these things, prefix and also suffix, the first thing is we need to know what does this prefix mean. Now we have understood what does this prefix mean. Now what does the prefix sum actually mean? The prefix sum actually mean with the sum coming from the pre itself means the previous elements, right? Now let us see. We need the sum prefix sum, a simple problem, right? A simple example so that you can understand the algorithm itself. So I am writing here, given array, given an array, return the prefix sum, return the prefix sum at every index, at every index, right? So given an array of size n, actually of size n, let me write it, return the prefix sum array which contains the prefix sum at every index, right? Let us see. Let us look at an example. Nums is equal to 1, 3, 5, 2, 4, 6. Now, here the array need to be returned like 1 and 1 plus 3. 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 2 is 11. 11 plus 4 is 15. 15 plus 6 is 21. So the output array is like this: 1 and then 4 and then 9 and then 11 and then 15 and then 21. Let me write the algorithm and then I want you to try the code for this, right? So first, 1 is added to 3 and it became 4. 4 is added to 5 and it became 9. 9 is added to 2, it became 11. 11 is added to 4, 15. 15 is added to 6, 21, right? Wait a second. Oh, excuse me. Now, we are adding the pre-sum, let me name it as pre-sum array. Pre-sum of I is added to nums of I plus 1, or nums of I plus pre-sum of I minus 1 is added and it is stored in pre-sum of I. Now, let us see here. Here, if you see, what if I am at index 0? That's the problem. Index 0, 1, 2, 3, 4, 5. Now, what if I am at index 0? I am saying that pre-sum of I, the output array of I, is equal to nums of I. Nums of I is present, however. But pre-sum of I minus 1, 0 minus 1 is minus 1, which is not there, and it will return as a runtime error, right? So how can we skip this? We will initialize. Let me write the algorithm step by step. I have just said you the formula that presum of I is equal to nums of I plus presum of I minus 1, but we didn't have presum of I minus 1 when we are at index 0. So what we will do is presum of 0 will be will be nums of 0 itself, right? So here itself is prism of I. Prism of 0 is the nums of 0 itself. It is the same. There are no elements before this number or this element, this index, right? After that, we got 4 by adding nums of I to this, adding nums of I to prism of I minus 1, adding nums of I to prism of I minus 1. That's what I wrote here. Now what I'll do is I'll start from I is equal to 1 and go till I is less than n. So I want everyone, or however there are only 3 viewers, right? In just 3 minutes I need something like a code in your own language, so that I'll be waiting for 3 minutes till 8:25. Yes, if anyone doesn't comment their approach in the live chat, I'll be going with the code itself, right? Let me open the online compiler. Online compiler, right? Please let me know in the live chat that how can we exactly write the code for this in your own language, whatever it might be, Python, C++, or Java, right? So we'll be waiting for more 2 more minutes, right? So we'll be initializing the presum of 0 is equal to nums of 0. There are some cases that we don't know what is this n. The code doesn't know. The code doesn't know what does this n mean, and also what does this presum means, and also what is this I means. And then we need to return the nums this presum at the end. Just print or return presum at the end. Presum at the end. So I need to know like what will be the code for this in your own language. We'll be just starting the code in 1 minute, but if you knew how to implement this in code, please let me know in the live chat or chat box, right? So we'll be waiting for 1 more minute. Yes, this is just an easy thing. That prism is a easy thing if you knew that hash maps also, right? If you knew hash maps and also prism, you can easily implement any prism problem, right? And also this prism can also be used in trees and also graphs, right? So we'll be starting with the code. First, let us take input of n, right? Daily code. Hi bro, how are you? Right? Okay, so we'll be starting with int n and then c in n, and then let us construct an array of nums. So we'll be doing with the need code 150 problems, but not in the specific order. We'll be uh, taking the ones which are given in prefix sum topic, right? We'll be going topic wise. So there will be like 6 problems we'll be solving today, right? Some of the codes I have already solved, some of the problems that I have already solved. So we'll be starting with those codes, those problems, right? So let us construct a nums array. Right now, let me take the input for int I is equal to 0, I is less than n, I plus plus, c in array, or sorry, I have given nums as the input vector, right? So C in nums of I is nothing but taking the input nums of I element. Now I have initialized the vector of int nums. It knew what does the nums mean. Now I'll initialize. I said I don't know what does this pre-sum mean. So vector of int pre-sum with the same size of n. But I have initialized. After that I have said pre-sum of 0 is equal to nums of 0. So let us do that. Pre-sum of 0 is equal to nums of 0, right? Now after that I said I'll start the loop from I is equal to 1 and go till less than n, and pre-sum of I is equal to nums of I plus pre-sum of I minus 1. Let us implement that. For int I is equal to 0, I is less than n, I plus plus pre-sum of I hope this is visible to you, right? Yes, pre-sum of I is equal to nums of I plus pre-sum of I minus 1. Then let us print the output. For int I is equal to 0, I is less than n, I plus plus see out pre-sum of I, and then give a space, and then let me give a line as the output. Let us do the same thing. 6 is the size and 135246. 6 is the size, 135246. Let us run the code. If you are having any doubts, please let me know. Right? So today is the day 4. I have missed the yesterday's day streak. Right? I wasn't there available. Right? That's why I wasn't on a live session. Right? So this is just very slow. Let us see our other online C++ compiler. Yes, C++ online compiler. One three five two four six. No, I think there is a problem with the internet connection. Everything is perfect, but online C++ compiler. This is the better one, I think. Right? So I'm giving the input 6 and then 135246. 135246. 149 11 15 21. Let us see. 149 11 15 21. Right. Okay. We have executed it, right? So I think you might got what does the prefix sum mean. This is just about the prefix sum, right? How do we implement the prefix sum? And let us see. After that, let us see about the problems which are included in the prefix sum, right? Let us see. Okay. Now let us go with the first problem. First, let us go with the first problem. Subarray sum equals k. This is the problem number 560 and problem number 12 in NEET code 150 problems, right? So let me give you the link in the live chat or chat box, right? Let me give you the link and let us see how can we solve this problem. I think it might take 3 hours today as we are solving 6 problems for this session. 560 sub array sum equals k. Sub array sum equals k. Let us see how can we solve this. Okay. Given an integer array of nums, integer array of integers nums and integer k. Excuse me. Right. So I have given the problem link in the live chat. So given an array of integers nums and an integer k, return the total number of subarrays whose sum equals to k. Okay, a subarray is a contiguous non-empty subsequence of elements within an array. Let me tell you what is the intuition I would get, or what is the brute force approach I would follow. First thing, what is the brute force approach I would follow for this problem? Let me tell you that, and then I'll be going with the prefix sum afterwards. Let us see. Okay, I am giving the description at the left side, and let us see how can we implement this with brute force approach. Brute force is nothing but the approach which you get ran like without any optimization or complexity, without worrying about any of these things, right? So I think the link is available for you. Okay, now let us see. Subarray sum equals k. Subarray sum equals k. This is the 560 problem number 560 in lead code. This is about a prefix sum. But however, we'll be going with the brute force approach first. Let us see what does the brute force approach mean. First, let me understand what is given in the problem. Given nums as the array and an integer k. Return subarrays, return subarrays whose sum is whose sum is k. Okay. We need to return the total number of subarrays whose sum is equal to k. Let us take an example, and then let me go to the constraints here. The constraints are the n can be 2 into 10 power 4, which is quite large, and the nums of I can be minus 1000 to 1000, and then minus 10 power 7 to 10 power 7. The k might be from 10 power 7 to 10 power 7, right? If it is like 10 power 7, I think we might use a long data type. Okay, let us see here. Take an example, 1 comma 1 comma 1. This is the nums array given to us. Then k is given as 2. We need to return the total number of subarrays whose sum is equal to k. Let us take a subarray. This is the first subarray. Okay, let me write all those subarrays. Subarray, this is a subarray, and then again, this is a subarray, again, this is a subarray, right? Now, this is a subarray too. This is a subarray, and then this is also a subarray. Yes, this is also a subarray, and then the whole array is also a subarray. 1 comma 1 comma 1. So totally how many subarrays are having a sum of 2? We also need to know the sum. It's not that we got the subarrays itself. So the sum is here 1, the sum is here 1, and the sum is here 1. Here it is 2, here it is 2, here it is 3. How many subarrays are having the sum of k? Nothing but 2. One subarray, the second subarray. So we'll be returning the answer 2, right? Let us take another example and understand this clearly, right? Given nums is equal to 1 comma 2 comma 3 and k is given as 3. Now let me write all those subarrays, right? All those subarrays as the previous one. This is a subarray, right? This is a subarray. Okay, this is also a subarray. Now, this is also a subarray. Now, this is also a subarray. 1 comma 2. Now, this is also a subarray. 2 comma 3. Now, the whole array is also a subarray. 1 comma 2 comma 3. Now, there will be a pattern here. I'll tell you what is the pattern there, right? So, let us see what is the pattern there. Now, if you see, what is the sum for this subarray? 1. For this 2. For this 3. For this 1 plus 2, 3. For this 2 plus 3, 5. For this 1 plus 2 plus 3 is nothing but 6. Now, how many subarrays are having the sum of k? Nothing but 3. So, this is the first subarray and this is the second subarray. So, totally I am having 2 subarrays and I will be returning that itself. But if you observe, I said that there is a pattern behind here. 1. If I add 2, I got 3. Now for this 3, if I added this 3, I got 6. Now imagine, just imagine there is another number like 5. 1, 2, 3, 5. Just imagine hypothetically that if I have 5, then no need to iterate from the starting 0 to this index 3. No need to do that. If I knew what is the sum till now, till here, if I knew I stored this here, then I would clearly add that to this 5, right? 1 till that index, it is just 1. For 2, add the previous sum, 2 plus 1, 3. Now I have a 3. Now I don't have to iterate from this index. Why? Because till here, let me tell you, till here I have stored that here, till here, right? Till index 1, the sum is stored in an array that is named as pre-sum, right? Nothing but prefix sum. Now, what I'll do for this, till this index, I also need to know the sum from the index 0. What I'll do is just add the previous prefix sum of I minus 1 to this 3. So 3 plus 3, I would get 3 plus 3 as 6. Now 6 is added to 5, I will get 11. So totally this will be our prefix sum array. You might understood this. If you do not understand this, please let me know in the live chat. But if you knew it or if you have understood it, please like this live session, right? Or hit a like in this live session, right? Okay. I think everyone understood. Like there are only 4 people, however. So I think you have understood this this thing of prefix sum. Why are we doing like that? Now I'll tell you that. Let me tell you here. Let me take a number, a nums array which is quite large. The given nums arrays are less. I think they are of the you know they are of the less size. Okay. Now 1 and then 2 and 3 and 1 and then 3 again and then 5 and then 2 and then 1 1 1. Let us see. Given k is equal to 3. Let us see here. What are the subarrays which have a pre-sum or which has a sum of k? Let me identify all of them. So let me start with this. Is it a will it give me a sum of 3? No. So count is equal to 0. Now 1 and let me take every element 1 by 1. 2, will it give me? No. Will it give me? Yes. So 1, will it give me? This will not give me. This will give me. Yes. So 2, this will not give me. This will not give me. This no. This no. This no. Let us take with the size of 2. 1 plus 2, will it give me 3? Yes. 1 plus 2 is 3. So let me increment the count. 2 plus 3 is 5. No. 3 plus 1 is 4. No. 1 plus 3 is 4. No. 3 plus 5 is 8. No. 5 plus 2 is 7. No. 2 plus 1, 3. Yes. So increment 1. 1 plus 1, no. It is 2. 1 plus 1, no. It is 2. Now, let us take the size of 3. 1 plus 2 plus 3, 6. No. 2 plus 3 plus 1. Again, it is 6. No. 3 plus 3 plus 1, 7, no. 5 plus 1 plus 3, no, it is 9. 3 plus 5 plus 2 is 10, no. 5 plus 2 plus 1 is 8, no. 2 plus 1 plus 1 is 4, no. 1 plus 1 plus 1 is 3. So, I got 5 subarrays. Do you think I'll get more subarrays if I took the size of 4? Let us see. How dumb I would be if I took the size of 4 and every element will be here every element is greater than 0, right? If I am taking 4 elements and every element will be greater than 1, the minimum value will be 1 itself. However, it will give me at least 4 as the sum. So taking 4 elements as the subarray or the size of the subarray as 4 will not give me the answer. So I have the count as 5. Totally, I have the count as 5. I'll return the 5. But if you see, there is a pattern here. Let me tell you that 1 plus 2 has given me the sum of 3. Now, if you see here, I will be getting the sum of 6. And then here 7, and then 10, and then 15, and then 17, 18, 19, and then 20. If you see, let me tell you, I got 3 and then I got 6. First, I was at 1. Now, when I got 3, 3 minus 3 is 0. Let us skip that. Now, let me tell you, 20 minus 3 is 17. Till here, till this index, if I remove 3, then I would get 17, right? I would get 17. So how many times I got this 17? Let me tell you how many times I got this 17. Nothing but 17 is nothing but 20 minus 3, it is 17. So if I was starting after that 17, the sum after that 17 is 3. That's it. Let me tell you. I am saying that after that 17, if I add 3, I would end here. So why not think in reverse? If I remove 3, I would get a 17, and how many times I got this 17? Those many times I would increment the count. That's it, how clear it will be. So 17 plus 3 is 20, but 20 minus 3 is equal to 17, right? So if I am having the pre-sum of 20 minus 3 is 17, the pre-sum is 17, right? So if this 17 is present, that means if this 17 is present, let me tell you for one time, that means there is a possibility, there is only one possibility from this 17. Let me take this as 17. So 5, 5, and then 7. This is the array, and then 1 comma 0 comma 1 comma 1. Let me just take like this: 5 and then 10 and then 18, and then here 18, 19, and then 20. Here I am saying that 20 minus 3 is 17. That's the same thing. 17 plus 3 is 20. So what I'll do when I get a sum 3, I would do sum as something like pre-sum of I'll do minus 3. I got 17. I will ask previously all the elements. I need to store the pre-sum, right? Previous sums, right? So how many times I got this 17? One time. So this sub array is valid. After that 17, the sub array is valid. But there is a problem here. I got the sum as 3, and 3 minus 3 is 0. But there is no 0 previously, right? There is only 1. Even before this 3, there is no 1, no 0. Let me know in the live chart that here I got a 3. I am saying that 3 minus 3 is equal to 0. Let me just remove all of this stuff. So previously I got previously I am saying that pre-sum of I minus 3, nothing but pre-sum of I minus k. I will search for this. I will search for this. I got 0. But previously, before that, I didn't get anything. Everything, the only thing is 1. But if you see this sub array 1 and 2 is giving me and also contributing to the answer or the count of number of subarrays which add up to the sum of k, sum equals to k. So let me know in the live chat, how do I overcome this problem? I'll just use a hash map, however, to store the previous presums, right? I will use a hash map or an unordered map to store all the presums. So use hash map to store all the previous presums. Okay, let me know in the live chart. I set at this index 3 minus 3 is equal to 0, nothing but presum of I minus k equal to 0. But I don't have previously a 0. How do I get that? How do I get that? Right? So let me know in the live chat. Okay, if anyone doesn't reply, I'll be starting with the algorithm and also explain you why it will be and what we will be doing to overcome this problem in just 2 minutes. Exactly at 8:50, I'll be solving this. Exactly at 8:50, I'll be telling you what we'll be doing so that we'll be having the previous, we doesn't have any previous which is having a sum of 0, right? Let me know in the live chat how can we overcome this problem, this edge case, right? So only 2 minutes are left. So if anyone knew about this, anyone knew how can we overcome this edge case, please let me know in the live chat. Yes, we'll be starting this in just 1 minute, and also I'll be coding this, however. So in just 1 minute or few seconds, I'll be starting the algorithm, going with the algorithm. So it's just some seconds so that uh, you can say what we will be doing or what we need to do so that we can get our edge case passed. So yes, the problem is we are having this 3 and I said prism of I minus k. I'll be searching for this previously how many times I got and that count will be added to our answer, right? That's what I said. But here I got 3 minus 3, nothing but prism of I is 3 and k is 3. So 3 minus 3 is 0. But I don't have any 3 previously. How can I overcome this? So let me know. Let me write the algorithm here. First thing, use hash map to store all the previous prisms. Yes. Now, construct a prism array. Construct a prism array. Now, after constructing the prism array, what I'll do is I will just include a 0 into my hash map, right? So hash map will be like mp of 0 is equal to 1. That means I have 0 for one time. I don't have, but an empty array is having a prism of 0, however, right? That empty array will be having only 0. That's why mp of 0 is equal to 1. Now, I'll go, construct a prism array as I said. I'll start with the, wait a second. Someone has, wait a second. So I'll go with the prism array. I'll go with the prism array and if I had the difference, what is the difference? Prism of I minus k. If I had this difference previously, I will add that to the answer. So if I had to add that to the answer, I need to initialize answer is equal to 0, right? So start from I is equal to 0, I is less than n in pre-sum, right? Pre-sum, right? So what is the difference? Difference is nothing but pre-sum of I minus k. So if nothing but let us say answer plus is equal to MP of difference. That's it, right? That's it. Now at the last return the answer. But if you see, I got the prism, right, but it isn't starting off. It isn't included in the unordered map or hash map, right? So that's the error here. I just missed it. How many times? I don't know how many times I would be missing this updating of MP. So MP of prism of I, prism of I plus plus, right? So this is how I'll be solving this, and let me do the code part first. Let us start with n. Int n is equal to nums nums dot size. Is there anything we need to initialize? Yes, answer is equal to 0, and then first vector construct a prism array, and also we need to initialize an unordered map int comma int mp. Now construct a prism array vector of int prism of n comma 0 n comma 0. Now prism of 0 is equal to nums of 0, right? For int I is equal to 1, I is less than n, I plus plus. Pre-sum of I is equal to nums of I plus of pre-sum of I minus 1. Now after that, construct a pre-sum array. Yes, we have constructed, and MP of 0 is equal to 1, and answer is already initialized. Now for int I is equal to 0, I is less than n, I plus plus. Now int difference is equal to pre-sum of I minus k, and answer plus is equal to MP of difference, MP of pre-sum of I plus plus. Then at the last return the answer. Yes, I have run the code, but let me hope that it got, yes, it got accepted. Let me submit the code. Yes, time taken 24 minutes. Okay. So yes, it got accepted, but if you have any doubts regarding this problem, and also don't, this is nothing but Prism will be, there is a model like sweep line algorithm. Sweep line algorithm. I'll be discussing when I will go with the next sessions. But sweep line algorithm is also a beautiful algorithm. It will be used for meetings and also that kind of problems. So if you have any doubts regarding this problem, please let me know in the live chat. Right? So we have solved only one problem, but it's still like we already went through 40 minutes for this live session, right? But however, we'll go to the next problem. But before that, please let me know, right? It is nothing but watching this live session in your mobile without any practice will not help you, right? Find pivot index. Given an array of integers nums, calculate the pivot index of this array, right? Count number of, this will be the third problem, right? And the remaining three problems I'll be giving you with the practice, the remaining three problems. So I'll be solving this problem and also this problem, 17.4 and also 12.48. Let me give you the problem link in the description. Oh, sorry, not in the description, in the live chat. Find pivot index. Yes, let us see. Wait a second. Let us see how can we solve this in just few minutes. Okay. Okay, I have given the problem link in the description, right? So we'll be solving the three problems and then the three problems will be given for the practice. So pivot index, what does this actually mean? Given an array of integers nums, calculate the pivot index of this array. The pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right. Nothing but, let me tell you, 724 pivot index. Let me tell you, 724 pivot index, right? Let me tell you, we need an index. We need to return the index. Okay, we need to return the index where the sum, left sum, left sum is equal to the right sum. You might say, you might be getting an algorithm like get the right sum and also creating two separate arrays for left and left sum and also right sum and going through this index. It is also right, but we are using much space complexity. I'll explain you that also, but let us implement the brute force approach first. What is the brute force approach? First, let us start with I is equal to 1 and go I is less than n minus 1. Why? Because if we, this is n minus 1, this is n minus 1. I need an index such that the sum to the right is equal to the sum to the left, right? So if I am at this index, there is no element to my right. So this will not be our index. So we'll be ending at I is less than n minus 1 itself, right? So I is equal to 1, I is less than n minus 1 and I plus plus. Is, what I'll do is I'll initialize left sum is equal to 0 and right sum is equal to 0. Now for left sum, for int j is, let us take L instead of j. L is equal to 0, L is less than I and L plus plus, left sum plus is equal to nums of L. This is how I'll get the left sum. Now for int r is equal to 0, no, r is not equal to 0. R is equal to I plus 1 and r is less than n. I'll start from I plus 1 after that index. I plus 1, r is less than n, r plus plus. Right sum, right sum plus is equal to nums of r. Okay, I got this too. Now if left sum, left sum is equal to the right sum, then return the index itself. Now if the return the leftmost, no, wait a second, return the leftmost pivot index, nothing but the the first one, the first pivot index which we get. If no such index exists, return minus 1. So if we got it, we'll return I. If we didn't get it, we will return minus 1. That's it. This is as simple as that. If we go with the brute force, however, we'll be optimizing it. Let us see. First, we need to initialize int n. Int n is equal to nums dot size. Okay, for int I is equal to 1, I is less than n minus 1, I plus plus. Int left sum is equal to 0, right sum is equal to 0. For int L is equal to 0, L is less than I, L plus plus. Left sum plus is equal to nums of L. After that, for int R is equal to I plus 1, I plus 1, R is less than n, R plus plus. Now write sum plus is equal to nums of R. If left sum is equal to right sum, then return I. Return I. If not, return minus 1, as we didn't find any index, right? So I might get a TLE if I submit it. Let me check the constants. Yes, the constants are till 10 power 4. That means we will absolutely get the TLE, right? Okay. So the question is the same as 1991. Okay. We will also submit there. No, we got a wrong answer. Output is minus 1. Index expected 3. 173656. Let me do a dry run for this. 17365 and then 6. Okay. L is equal to 0. L is less than I. Sorry. R is equal to I plus 1. I did a mistake here. R is equal to I plus 1. But I have initialized R is equal to R plus 1. Let me run this. No. 2, 1, minus 1. Okay. Output is minus 1, but expected 0. So, the left sum, if it is at 0, it will be okay. Okay, I have understood this, right? So 2 1 expected 0, right? Okay, let us start with I is equal to 0 and let us also go. I thought that we won't get it, but if I is equal to 0, left sum is equal to 0 and sum, yes, we got the right sum. However, yes, we got the right sum. However, okay, let us see. Let us write this. However, right. So first, left sum is 0, right sum is 0. Now let me do this. Yes, nothing but we are not going to 0 and also n minus 1. But here we went to 0 and also n minus 1. I have run the code. Sorry, run the code again. Let me submit it. It might give me a TLE. However, let us just optimize this again. No, it got accepted, but let us optimize this by using two arrays. We can use one array, however, I'll explain that too. Now, that example was beautiful. 7 6 something. Yes, here 173656. 173656. Let me show you that left sum. Let me say here I am taking like every time I am iterating through the array. So it will give me here big O of n and then here big O of n. Totally it will give me like big O of n square, which is much greater, right? It is not optimized. It is however brute force. At left sum, let me initialize 1. 1 plus 7 8, 8 plus 3 11, 11 plus 6 17, 17 plus 5 22, 22 plus 6 28. Now let us write, let me write it like this, write sum as I am going from the right. 6 here, 6 plus 5, 11 here, and 11 plus 6 17 here, 17 plus 3 20 here, and 20 plus 7 27 here, 27 plus 1 28. If you see 28 and 28, that means we did in our calculation part. Good. Okay, now I'm at this index. Left sum is 0 but the right sum is 27. No, they are not equal. I'm here, left sum is 1 and the right sum is 20. No, they are not equal. Here, left sum is 8, right sum is 17. No, they are not equal. I'm here, left sum is 11 and the right sum is also 11. So they are equal. I'll return this index where I am at 0, 1, 2, 3, 4, 5. I think this is 5. Yes. 7 plus 3 is 10 plus 1, 11. 5 plus 6 is 11. Yes. What I'll do is, let me write the algorithm first. Algorithm is nothing but create two pre-sum arrays, left sum and right sum. Okay, let me say that here, when I am at I is equal to 0, the left sum will be 0. When I is equal to n minus 1, right sum will be 0. So what I'll do is I'll go from I is equal to 0 till I is less than n, however, but left sum is equal to let me say that L. Let me say that as L sum, left sum is equal to, if I is greater than 0, then left sum of I minus 1. If not, it is 0. Now right sum is equal to I is less than n minus 1, then right sum of I plus 1. If not, it will be 0. That's it. I'll be writing like this. And if L sum is equal to R sum, I'll return I. If not, return minus 1. Let me code this up. I'll initialize, as I said, I'll initialize two pre-sum arrays. So, okay, wait a second. Here I got it with a brute force, however. Okay. Create two pre-sum arrays. Vector of int left sum is the name of the left sum array, n comma 0, and then right sum is also n comma 0. For int, let me tell you how can I initialize this left sum with. Left sum of 0 is equal to nums of 0. Right sum of 0 is equal to nums of, sorry, n minus 1 here, sorry, right sum of n minus 1 is equal to nums of n minus 1. Okay, now for int I is equal to 1, I is less than n, I plus plus, left sum of I is equal to left sum of I minus 1 plus nums of I. Then for int I is equal to n minus 2, I is greater than or equal to 0, I minus minus, right sum of I is equal to right sum of I plus 1 plus nums of I. Right? I think there are no errors. N minus 2. Okay. Okay. There are no errors for now. For int I is equal to 0, I is less than n, I plus plus. First, int L sum is equal to, if I is greater than 0, then left sum of I minus 1. Left sum of I minus 1 and then 0. int r sum is equal to, if I is less than n minus 1, then write sum of I plus 1 and then 0. If L sum is equal to R sum, then return I there itself. If not, return minus 1. I just run the code. It got accepted. Let me submit it. Yes, it even though it is not true, this, as many people said that it is not true, beats 100% and all. So creating two pre-sum arrays, what is the time complexity? Big O of n for left sum array plus big O of n for right sum array plus this one to calculate or to know whether there is an index, pivot index, big O of n totally. Big O of 3n is the time complexity. Now, what is the space complexity? Now, let me tell you what is the space complexity. I am initializing two arrays, left sum and right sum, right? Uh, all the other are just constant space, right? They are like big O of n is for left sum and big O of n for right sum. So totally big O of 2n is the space complexity. So we can even reduce this and also this. Okay, let us see. Let us see how. How can we reduce it? If I knew, if I knew this one, only the left sum, only the pre-sum, I can easily solve it, right? Let me show you how. Let me show you how. So till here, it is the 11 as the sum. It is 11 as the sum. 11 as the sum. Okay. Okay. 11 is the sum. Wait a second. 11 is the sum till here. Now, I need to get the sum after this. What if I just, what if I just did like this? Wait. Till here, it is just 11, right? Till here, it is 70. Now, where did I get this? Okay. Okay, let me take this index itself. This index itself. Previously, I got 11 as the sum. Now, I want the sum from here. So, what if I remove the sum from the starting to this index? What if I remove this sum? Right? So where does this sum is present? So the sum till here is present here. The sum till here is present here. So the sum till here is, if it is removed, 28 minus 70 will give me 11. So 11 is equal to 11. We will return the I. Now when I am at here, that's the only problem, right? When I am at here and also when I am at here. Okay, there only I would get a problem. So I'll solve the things like this itself. If I'll just change it. If I is equal to 0, L sum is equal to 0. If not, L sum is equal to I minus 1. Okay. Okay. If I is greater than 0, L sum is equal to I minus 1. If not, it is 0. Yes. Yes, it's the same thing. We do the same thing, however, but instead R sum will be, let me tell you what the R sum will be. Let me write it again. Let me write the algorithm first. Get the pre-sum array done. After that, what I'll be doing after that? So if you see what I'm doing here is I'm iterating from I is equal to 0 till I is less than n. So for I is equal to 0 till I is less than n, L sum is equal to, if I is greater than 0, if I is greater than 0, then it will be pre-sum of I minus 1. If not, it will be 0. Now R sum, if I is less than n minus 1, if it is n minus 1, then only pre-sum of n minus 1 minus pre-sum of I. Pre-sum of I. But however, if you see, even if it is n minus 1, right, no need of this I is less than n minus 1 or not. Why? Because removing the same 28 minus 28 minus 28 will give you 0, however, right? Now, when, yes, when I am at n minus 1, pre-sum of n minus 1 minus I will give you 0, however. Now when you are at this index, pre-sum of n minus 1 minus I will give you the sum for this, from this, right? Okay, so the R sum will be pre-sum of n minus 1 minus pre-sum of I, right? So the same thing here. If L sum is equal to R sum, return I. If not, the after this loop, return minus 1. Let me tell you here, I'll initialize that as pre-sum of n comma 0. Pre-sum of 0 is equal to 0. Pre-sum of 0 is equal to 0. Let me take this left, wait, 0, and then control V, then here. Now remove this. Now L sum is greater than 0. Pre-sum of I minus 5. Please C, control V, wait, control C, control V. Now here write sum of minus I, left sum, pre-sum of I, pre-sum of I, pre-sum of n minus 1 minus pre-sum of I. That's the R sum, right? So if L sum is equal to R sum, return I. So let me run this. So this will take big O of n is the, wait a second, this will take big O of n. Wait a second, I think I wrote it in, yes, okay. The time complexity is big O of n. If you see, the time complexity is big O of n. Now what about the space complexity? The space complexity, we are using only pre-sum, so it will be also big O of n. So big O of n and big O of n, which are much optimized than the previous. Let us see, let me submit the code. If there is any error or any edge case, no, it got accepted, but it is much optimized than the previous two. First the brute force one, then the better one. This is the optimal one. So if anyone asks me, or anyone wants me to explain, then I'll be explaining in this flow. First the brute force, and if there is a better approach, then I'll be going with the better approach, and then I will go with the optimal approach, right? So yes, we have solved the second problem also. Now let us go count number of nice subarrays. Wait, can count number of nice subarrays. However, I'll be giving you three problems for practice. Right. Let us see. Count number of nice subarrays. However, we'll be going with the brute force approach first. Given an array of integers nums and an integer k, a continuous subarray is called nice if there are k odd numbers on it. Return the number of nice subarrays. Okay. This is quite, it might not be tricky for you, but for me it is a tricky one. Double 1 2 and then 1 1. Let us see. The k is equal to 3 is nothing but continuous subarray is called nice if I think it's the same thing. Yes, I think it's the same thing. Let us take, however, 5 minutes of break. I'll be starting this at 9:25. We'll be resuming it, this live session at 9:25. Yes, I just uploaded a reel, a short, sorry. So we got 8 not 8 subscribers, right? Let us increase our subscribers. 9th October, 16, 11, 61. Let us go with the live subscriber count. So I'm expecting at least 850 subscribers till we end this session. Okay, let us see how can we solve this problem. But before that, in just 2 minutes, we'll be starting this at 9:25 p.m. Taking a 2 minutes of break, right? It's a break time. Can we solve this by using the same thing? Right here, I got the sum. Instead of the prefix sum of the elements, what I will do is I will just take the sum with I'll just increment the sum only if I got a number which is an odd number, right? Okay. So if you see 11211, right? So we'll be starting this. Let me take a break of just 1 minute. Let me just take a break of 1 minute, right? I'll be soon back. I'll be closing my door. Can we solve this by using the same thing? If you see, I'm adding nums of I plus prism of I minus 1. Okay, nums of I plus prism of I minus 1. Okay, let us see 11211. Let me write it over here. 1248. So the problem is 1248. I will give it in the chat box. Is the link visible for you? Right? Can you open the problem link? Let me know in the live chat. Okay. Okay, let me know in the live chat. Is that link visible to you? Can you open that problem link? Count number of subarrays, double one, 1248, right? 1248, lead code 1248. Count number of nice subarrays. Count number of nice subarrays. Let us go with the first nums is equal to double one, two, double one, where k is equal to 3. Nothing but a continuous subarray is called nice if there are k odd numbers in it, given k, right? So taking these three will give me a nice subarray, and also this is also a nice subarray because there are k number of odds. But if you see, if there is an odd number 1, 1, 2, 1, 1, what I will do is in the pre-sum array, I just added 1 and then 1 plus 1, 2, 2 plus 2, 4, 4 plus 1, 5, 5 plus 1, 6, right? But I will not do that again. If it is only odd, then only add 1, and then here I got a 1. I will add the previous pre-sum of I minus 1 to this 1. No. If it is odd, I will add pre-sum of I minus 1 plus 1. I'll store it here. If not, pre-sum of I minus 1 plus 0. Let me write it clearly. If odd, add pre-sum of I minus 1 plus 1. Else, it is even, right? Else add 0. So, double 1, 2, double 1. Double 1, 2, double 1. If it is odd, add pre-sum of I minus 1 plus 1. If not, add pre-sum of I minus 1 plus 0. But what if I just counted number of odds instead of this pre-sum of I minus 1? Let me tell you. Here I got 1. Odds is equal to 1. Now I got a 1 again. At this point I got a 1. That means it is an odd number, so odds will be incremented to 2, and then here it will be 2. Now here I got an even number. Do I need to increase it? The number of odds till there are just 2, so it will be 2 here itself. Now I got a 1, so I'll increment it to 3, so it will be 3 at that place. Now I got a 1 which is an odd. I'll increment it to 4, so it will be 4. 1, double 2, 3, 4. This is my pre-sum array. Now if you see, for the same algorithm which I have explained you about, subarray sum equals k. Instead of the sum, I am taking nothing but the same sum. 4 minus k, nothing but 4 minus 3 is equal to 1. Do I got a 1 here? Yes, I got a 1 here. Now if you see, 3 minus 3 is equal to 0. Do I have a 0 here? No. But what I said is I'll store in the hash map MP. For 0 I have 1, right? Okay, let us see. For 0 I have 1. Now for 1 I have the count as 1. For 2 I have the count of 2. For 3 I have the count of 1. For 4 I have the count of 1. What if in a case I got it like this? Let me tell you. 4, right? I got 4, right? So what if I am having 5, 7, 8, 9? Okay, let me extend this array, right? So I have 5, 7, 8, 9. Then till here I have 4, and then I have 5, and then 6, and then 7. Now if you see, if I remove this 3, till here I got only 3. So 7, sorry, till here I got only 4. If I remove 4, nothing but 7 minus 3 is equal to 4. I am removing 4, right? So how many elements are there in the subarray which are odd? 5, 7, 9. So I got 4 for one time, so I'll just increment it, right? So that's how we'll be solving this, but let us see how can we implement it. Int n is equal to nums dot size, and I just need odds is equal to 0. Let me tell you, odds is equal to 0. Then is there anything else? No. Answer is equal to 0. For int I is equal to 0, I is less than n, I plus plus. I need an unordered map previously. Unordered map int comma int mp. So mp of 0 is equal to 1. First thing is, if nums of I mod 2 is equal to 1, then odds plus plus. Then here itself, wait a second. Here itself, I needed like the difference, right? So what is the difference? Int difference is equal to odds minus k. Now answer plus is equal to mp of difference. I'll add that, then return the answer. But as I have said that mp of odds plus plus. Let me run this first. Yes, it got accepted. I think yes, it got accepted. Let me submit the code. I think this is like a big O of n time complexity, and also am I using any additional space? Yes, unordered map, right? So the time complexity is big O of n, and the space complexity is also big O of n. There is no, I think there won't be anything much better than this in the time and space complexity for this problem. If you are having any doubts regarding prefix sum or these three problems, please let me know in the live chat. I'll be giving you the practice problems in the description at the end. So we'll be ending this in 5 more minutes. So if you are having any doubts, please let me know in the live chat. So the target here I have set is at 50 subscribers till we end this session, but let us see. Let us see, can we hit the target? So in 5 minutes we'll be ending this session, right? Okay, I think no one here. Okay. So yes, we'll be ending this session in 5 more minutes at 9:40 exactly. So if you are having any doubts regarding this session, let me know in the live chat, and also let me also give you my LinkedIn profile. Yes, we'll be ending this in 3 more minutes, right? So the live session was, of course, a less time, as this prefix sum is a lesser one, right? It is just like a basic concept like hash map and also an array. Yes, we'll be ending this in 40 seconds, right? So you can correct me in LinkedIn as I have given you my profile link, right? Yes, we'll be ending this session just 24 seconds, and I will give you the other three problems for practice as I have already told you about that.